All right, Unit 10, Formative 1, Video 3, scatter plots. So scatter plots are going to be our first quadrant, so we have our X and our Y, and the data is just scattered throughout the graph. So it's not a perfect line, okay? So this could be time, and this could be amount, okay? And we just graph data, and it's just scattered throughout the graph. So these are what scatter plots look like. All right, so first of all, before we do scatter plots, we need to know what correlation is and causal relation, okay, because we're going to use these two. Okay. So a correlation is two sets of data are strongly linked, but no evidence that changes in one variable will cause changes in another. For example, number of mailboxes in a city. Okay. Now, if there's a lot of mailboxes in the city, okay, so that's a high number, you can say that the number of firefighters also increases. Okay, right? Because usually the more houses, the more firefighters are needed. But they don't correlate. You know, if we add 2 mailboxes, we don't get 1 firefighter. Okay, so one, just because one changes doesn't mean the other one changes in the same relation. Okay, so all right, another thing is what we call a causal relationship. That's when one variable causes a change in another variable. So a good example of this, if we increase practice times for like swimming, we would assume our swim times would decrease. Okay, so the more we practice, the faster we're going to get. So that's a causal relationship. All right, so we're going to sketch the graph. Okay, a positive correlation. So we're going to do, again, everything is in quadrant 1. Okay, positive is what we've done before. The line's going uphill. Okay, so we have a whole bunch of dots, but, okay, they're going uphill. Now, a negative correlation, again, X, Y. Okay, this one's going downhill. Okay, so our dots start high and go down. Okay, so a couple things about uphill, what you need to remember is uphill both are increasing. Okay, your X value is increasing and your Y value is increasing. On a downhill, okay, as your Y value decreases, your X value increases, or vice versa. So a positive correlation, both sets of numbers are increasing. A negative correlation is when one's increasing and one's decreasing. Now, I don't have much room, but no correlation means that the dots are all over and there really is no pattern, like an uphill pattern or a downhill pattern. All right, so we're going to tell whether the following has a correlation, and if it does, is it causal, okay? The number of hours worked and the amount of money you made, okay? So hours worked increases, okay? Now, if you increase your hours of working, do you think your pay will go up? Okay? Yes, okay? So, and if you add more, like 2 more hours, then you're going to add more money, okay? So this is a causal relationship, because if one goes up, the other one will go up because of the other one. Okay? All right. And the amount of time you practice in your swimming. We already talked about this. So the amount of time. Oh, and this is a positive. So they're both increasing. Okay. Now the amount of time you practice in your swim meets. Okay. So now if we were sort of to look at this time, our practice time. If we increase our practice time, so it goes this way, okay, what do you think is going to happen to our swim times? They're going to go down, okay? So this would be a negative correlation. Okay. All right, so trend lines, a line that can be drawn through the data that best fits the data. Okay, given the graph, find the equation of the trend line. Now in this case, they actually drew the trend line for you, which is fine, but sometimes if there's no trend line, what we tend to do is we tend to draw the first point, or the first and the last point, and then draw a line through those. But when they didn't do this, but make sure when you draw your trend line that it goes through your y-intercept, okay, because we're going to need that number. Okay, so sometimes you're going to have to draw a trend line, sometimes they'll do it for you. Okay, all right, so we are going to go ahead and we're going to write the equation. Now remember, when you write the equation, it's y equals mx plus b. So we need to find the slope and we need to find the y-intercept. So the slope is rise over run. Okay, so now again, these aren't going to be exact. So okay, so you're going to have to do a little bit of guessing on this. So I'm going to guess that this point is about at 5, and then it goes up to here at 30. So to find the rise, it's going from 5 to 30. So that's 25. Okay, so you can take 30. I just took 30 and subtracted 5. Okay. Now my run, I'm guessing that's 750. Okay, so half of that, 4. So I'm going to guess this is about 100 is what I'm guessing. And then it's going to end over here, which I'm going to guess at 2100. Okay, so you see how I'm doing that? It's not perfect. You might guess different numbers. Okay, and then my run is going to be 2100 minus 100, which gives me 2000. So this is my slope. Okay, now again, don't worry about reducing these. Now my y-intercept, okay, is, I'm going to guess is 4. Okay, because it's a little below half. Okay, so our equation is going to be y equals, okay, 25 over 2000 x plus 4. Okay, now the next question says using your equation, so make sure you use your equation, don't just look at the graph and guess. What would the time be if the distance was 4,000? So we're talking about distance, which again is my x value. So I'm going to replace my x with 4,000. So I have y equals, I have 25 over 2,000. Now instead of x, I'm going to put 4,000 plus b, which is 4. And then I'm going to do this in the calculator. So I'm going to go ahead and put 25 divided by 2,000. Okay, equals, and then I'm going to take and multiply that by 4,000. And then I'm going to add 4. And I get 54. So my answer is 54 seconds. So it would be, it's going to be up over there. Okay. All right. So you will have to use your equation to find this answer on the test.